in Boston. A few starting updates. For Git, a number of you ended up creating massive archives by accident. This is a list of the repository size and the amount of storage you're using. And the goal is megabytes per week to have hundreds of megabytes per semester. And some of you have blown through that. So 2 notes on that. Learning to use Git is a dry run for the rest of the semester. We're going to teach you how to use machines where you can hurt the machine and the machine can hurt you. So last week I promised mistakes many of you will make, and many of you made them. As we progress, many of these mistakes are much more serious, and they're not at all a laughing matter. And so learning Git is an important skill, but it's also a dry run for mastering the kind of skills we're going to teach you. So right now, I'm in the GitLab class project with the issue tracker. As a reminder, you'll see I have my notification set to watch. To be sure, you should all be watching this project so you see the issues as email. I'm going to start one issue, which is on repo sizes. Find here. I'm going to post this link to the issue tracker. And then note, if you need your repo reset, ask here. So I just posted this issue. You should have all gotten an email message if you were watching the issue. And as I mentioned, it's hard to do surgery in the history of Git intentionally. That's an expert thing. If you made a mess of your repository and you want to start over, just post here that you need your repository reset to its start. Save the old one locally. Post here if you need your repository reset, and Fiori will reset the repos so you can do a do-over. Okay? And then also a note about the issue trackers.
What they told me, like, oh yeah, here I'm not.
Sorry, Waltham, you need to mute. A note about use of the issue trackers. You're encouraged to use the issue trackers to communicate, but remember, you have one for your own lab. Posting to this issue tracker goes to everybody watching, hundreds of people. So don't use this issue tracker as a shortcut to do homework. If you have a question, like my Git isn't working, you don't need the whole planet helping you because your Git isn't working. Start with your instructor and your local students. If you can't answer a question there, you should all be part of regional reviews. And if you can't answer the question there, go ahead and send it globally. You're invited to do it, but don't do it as a shortcut for doing local homework. Work locally, do your homework, and then go globally. Somebody needs to mute. Let's see, this says it's coming from Fiori. Fiori, double check.
No, I am muted.
To me, it's USA Boston Earth Accelerator.
Okay. Yeah, it looks like it's still Waltham. Okay. Yeah, now you're muted, Waltham, finally. Okay. So don't waste people's time, but use the global issue trackers for questions you can't answer locally. On schedule, we had a very lively recitation on version control last week with Fiori. Videos are posted at the videos link. And a reminder, we're doing recitations every other week. So no one next week. And then the one after that's going to be a fun one with Danielle, where you'll see lots of projects that grew out of Fab Academy into really exciting programs of things you'll be able to learn how to do. And then just one other schedule note, we found that this class was going to be on May Day, May 1st. and many people aren't working on May 1st. And so this class only, April 30, we moved it one day earlier, and that class is going to meet on Tuesday rather than Wednesday to not conflict with May Day. So with that, that's announcements, and we'll start in on the random review. This week, along with the weekly goal of meeting people, we want to go over workflows getting set up with Git and workflows for web development. And once again, we'll do about an hour of the random generator, and then we'll just open up for anybody to share questions or progress they had. Now, last week, I think the only person that came up that we didn't get to was TechSup, Ronaldo. So TechSup, are you there?
Hello.
Yep.
We are here too. Good morning here.
Yep. So we hear you. We're not getting video, but let's go with audio if that's what you have. Is Ronaldo there?
Now it's okay. Our video and our audio is working. The last time we couldn't speak because our audio was not working well. So now I am ready.
Okay. TechSup, your audio is fine. We're not getting video. So for the future, you need to debug your video, but your audio is fine. So let's go ahead. Is Ronaldo there?
No, already. Reinaldo is not yet. Probably town traffic is the problem. So I don't know if anybody else can speak now.
No. I'd rather just stay with the random generator. So when speak up when Ronaldo comes.
Okay.
Let's stay with the random generator. So we're going to meet Rudker from the VAG. Amsterdam?
Yes. Hello?
Yeah.
All right.
Okay.
I was just waiting to my colleagues and I was nervous to be picked out and ta-da.
So the random generator is very wise.
Apparently so.
Yeah. So it looks like you didn't get your site up yet.
Well, I did get my site up. Sorry, what's the question?
Okay, let's see. Okay. Sorry. I'm learning about this site framework. Got it. So tell us about yourself.
So yeah, basically this week I started from nothing. I didn't have any knowledge about using Git, using Markdown.
Sorry,
yes.
Rutger, go one step further back. Tell us about your background. Before we get to this week, tell us about yourself.
Okay. Well, I studied anthropology, but a few years ago I really enjoyed my passion in making. And actually I started off making jewelry, and if you scroll a little bit down, you can see one of the shows. So it's only the necklaces there.
Okay.
So basically I started off with doing that, and I really enjoyed it. And since then, I'm trying to master a few more techniques. And part of that, I was an intern last year at the WAG here in Amsterdam. And then I saw the FabAcademy, the students from last year, and I got excited. And well, here I am for this year.
Great. How do you make the necklaces? Talk about the processes you use.
Yeah, in that case, I use with molding. At first, I did it by hand. I actually work with plexiglass because it's then, the liquid, because there's a silicon, when you pour it, it's still a liquid. So it needs to be a solid base. So plexiglass, acrylic turned out very well for me. And later on, once I had a laser cutter myself, I started using the laser cutter to make my designs.
Okay, good. One of the fun units is going to be molding and casting, where you mill machinable wax, then you make tooling, and then can cast metals and all kinds of materials.
I'm looking forward.
Yeah. Good. Yeah, you'll have a lot of
pictures you see are mostly from bulk and just some random designs.
Yeah, not that you need to. You could do this whole class just on necklaces. Each week will be something to do with necklaces in a way.
Well, to be honest, my how do you call it? My passion shift a little bit. So I know a little bit of tricks, so I'm now keen on making some other more useful things.
Okay, good. So now let's catch up. Talk about learning Git and editing and.
Yeah, so what I mentioned before, I started from zero with this because I don't have any experience with this. Yeah, so the first challenge was basically to understand basically what Git is and what Git does. Next step was basically how to operate in a terminal, which turned out a quite big issue with me because I work on Windows 10. And
so,
yeah.
Sorry, 2 notes on that. So first of all, for everybody, just a reminder, what Rutger is doing is exactly what I want you to do, which is he's logging his work. He didn't simply just show I'm done. As he's working, he's logging what he's doing, what he's learning. That helps us follow along. It's a great habit for you for documenting your work, and you'll find a lot of other people learn from that. So this is a good model of what I'm looking for. Windows used to be a headache. It's not anymore. So once again, if we go into the project management meet, this class archive link, this is a real short version of the Linux subsystem for Windows. And so this is a radical change from Microsoft. If you search for Windows subsystem for Linux, what this does is you just do a couple of these steps, and then your Windows computer has a full Linux subsystem. Microsoft realized so much development is being done with those tools that needed to coexist, not fight. And so you just do this, and you get a Linux shell in your Windows computer. And then once you've done that, there's nothing Windows specific. You apt-get, you do all of the same things that you can do on a Mac or Linux from Windows.
Maybe, yeah. I still encountered some problem in uploading things in my files, for example, like pictures. I couldn't drag that to my local repository because it wasn't recognized in that sense, and I couldn't rewrite, if I say that correctly.
I don't understand that. So there's just a couple of potential issues. So there can be a difference between Windows and Linux in case sensitivity. So sometimes what goes wrong is you have upper extension JPG, but it's lowercase on the server. And another is the recurring issue of relative versus absolute file paths. So you want to make sure you're pointing, if you have a web page, you're pointing relative to where the file is, not absolutely where it is in the file tree. But other than those, there's no difference between doing this in the shell in Windows versus any other kind of computer. It's just a Linux subsystem in Git. I mean, were you able to resolve the issues?
Yeah, with a little bit of help in that sense, and a lot of trouble shooting on the internet, finding where the problems is. But mostly I turned out to do things manual and override the administrator rules. This is completely new world for me, so I'm not sure. I'm not familiar with the terminology.
Okay, to understand also. This week's topic of Git and the web development, the learning curve is sort of like that. This one is climbing a cliff. once you're up on top of the plateau above the cliff, it's a much more steady learning curve. This is just a lot of stuff you have to do to get started. But once again, mastering this is one of the most useful skills you'll learn here is this kind of content management. Okay, then you like MKDocs? Oh, what editor did you settle on? Sublime?
Yeah, Sublime. And I did that actually because you at least see the folders on the left side, which I kind of liked working with, like this, what you see now.
Yeah, all of these more powerful editors have versions like that. Sublime is a fine choice. Yeah, you're raising this. While you're raising it, let me belabor this. Actually, let me not belabor it. I'm going to talk about this today in the design tool class. I'll talk about image magic, and also a video equivalent and, how to use them for resizing. But this looks ahead to that. This is a great way to compress images for the web to manage file sizes. And, I'll give you a series of cheat sheets for these. Good. Yeah, so let's see, I'm trying to understand what you're running into. The cycle is you pull all your changes, you work locally, you commit, and then you push.
This week assignment was great for that, for learning the essentials at least.
Okay, and now a good thing you did is you don't need to do Git in the terminal. You can do it at GitLab. There's user interfaces, but people at all experience do it in the terminal or in their editor. And so it's what you did this week wasn't the easiest way, but it was a good investment in the effort for the week. Good. So your final project, let's see, Fiore, does your template have a final project place?
Projects.
Good. So something that's very important I strongly recommend is start a page on your final project now. Rather than doing the final project at the end, each week add a little bit more on your final project. So what are you thinking of doing?
Well, I kind of hope you get excited about the project. I was thinking of making a note lamp of all the different Fab Labs around the world that participating in the Fab Academy, and to create like a visual way of indicating who's online, who's not, maybe who's speaking, or maybe who wants to address some attention. I'm not sure if that's visible with my skills so far, but I'm going to look forward on making this project.
Yeah, oh, that's interesting. So do you want to just do Fab Academy or do you want to do Fab Labs?
Well, in the first instance, just Fab Academy, just to learn some skills. But I don't know. I like the concept of a Fab of a Fab Lab.
Yeah. So I'm trying to think. Some of this is straightforward. Some is more ambitious. So a fun exercise is in large format machining, we'll cover how to mill a big map. And there's a nice exercise to take the coordinates of the labs and turn them into points on the map. And then you can have lights for the labs, and then we'll cover how to make a network out of them. The interesting question, though, is how to measure activity.
There's an API in BlueJeans.
What?
There's an API in BlueJeans. So you can, by simply by using this API, seeing some, what's going on in BlueJeans.
Oh my god, I didn't realize they had an SDK. Oh, that's interesting. If you use the SDK and you pull data from it and then you send it to your map, we're working pretty closely with BlueJeans that we keep breaking their infrastructure and they keep growing to support it. And so I'm sure they'll be interested. We can share this with BlueJeans. They would be really interested in that. And yeah, so this is also a great example of spiral in that, like, a first spiral of the project is laser cut it and have Amsterdam blink. And then another spiral would be a large format version, but it's still just Amsterdam blinking. Then you have more LEDs, but they're blinking randomly. Then you have them networked, but not with the API. Then you have them with the API. And each of those is an example of a complete spiral. And so that goes from a tractable to an ambitious project. That's fun. I like it.
Thank you.
Okay, good. Thank you. UAE, Salam.
I need one moment. The student is praying and he will come back in 10 minutes.
Okay, I'll leave Salam up. Let me know when Salam is up. Dilijan, Mikael.
Oh, hello, I'm here.
Good. You get a prize for rapid response in the video conference. Good.
Thank you.
So first, talk about where you are. Talk about your lab in Armenia.
I'm from Yerevan, Armenia. Now at the present I study in third year at Faculty of Physics of Yerevan State University. And also I'm interested in engineering, electronics, and 3D modeling. So,
okay, good. And then talk about your site. What kind of framework are you using for the site?
So I downloaded HTML5 template. So make some changes on it, and now I have such a website.
Good. And so this is a reminder that Fiori gave you starting frameworks, but you don't need to be limited by that. You can download a template. If you get a little more ambitious, you can write your own template from scratch. There are students do all kinds of fun stuff. Let's see. The last time I did this at MIT, let's see. Oh no, it wasn't Ocean. I'll have to find it. One of my students made a site that was adversarial. The site was like a video game, and the week's assignments sort of kept moving away from you, and you sort of was a battle to navigate the site. She made it hard, not easy. So the sites can express however you want to represent your work. So it looks like, how did you do with Git and GitLab?
So I changed my operating system, so I switched to the Linux, and using a terminal, I tried to set up my GitLab.
Yeah, and just a note again, just to repeat on Linux. Linux, I use, a lot of development is done in it. Just to repeat, if you're using Windows, Windows now has this Linux subsystem that gives you Linux.
I know.
Sorry, just a minute. And the other thing is, let's see. Let me just go back to a link. This is not for you; it's for everybody else. The schedule, project management, class archive, and then for Mac, I have a link here to Homebrew. And Homebrew is like the package managers used in Linux. And so any of those three things end up converging around the same place. But I prefer doing this in Linux. Go ahead.
Yes, and so I like kind of double boot my system, so I can same time in Linux and Windows. But in future, I think I will completely change my operating system to Linux because I like it very much.
Okay. One more nice thing about Linux is, aside from the ease of customization, as we get to things like talking to embedded devices in real time, it generally behaves better for low-level interfacing. That you end up not tripping over as much the operating system when we
Yes.
get to things like device interfacing. Okay, so then
So here I show how I develop my website. I
okay.
use like
So sorry,
uh,
I see. If anybody's in SEPT, you can let Rutuja Patel know that he likes her site and he's starting from her site.
yes, I looked to 2018 course and website, so I find which I like and use.
Good.
So I show the commands and how you download it, template and stuff like that, and step by step.
Then this is all good. There are, the Markdown site generators, the WYSIWYG site generators. I find I actually prefer just writing native HTML. It's very easy to learn, and you have
Yeah.
more control. So, and it's not heroically difficult. Good. Okay, and so you like Atom?
Yes, I kind of like Atom, but at the same time, I use sometimes Visual Studio Code. So kind of both of them at the same time.
Okay, they're both powerful, both fine choices. Good. And again, this is all good versions of documentation as you're working. You'll find you outsource parts of your brain to your website. And so typically you'll find you go back to your own website to remind yourself of what you've learned.
Yes, I kind of make blogs and mash it together, and also I use Git Kraken, which is a very powerful tool to manage your content.
Yeah.
Also, you can download it on Linux store.
Yeah. And so Git Kraken is one of the nice GUIs. You can do all of this from the command line, but it's a nice GUI interface.
Yes.
Some people love these, some hate these. There's no right choice. It's just personal. Okay, good. That sounds like a good week. And then final project. What do you want to do?
So my final project is I want to make a desk which is fully wireless charger.
Sorry, I'm looking. This link isn't working. Do you have a page on your project?
Yes, week 1.
Okay.
Okay.
You can go ahead.
Make a desk which is fully wireless charger. So wherever you put your device on the surface of the desk, it will charge, and it can charge several devices at the same time. Also, I'm thinking to make a receiver for computers, to put this receiver under the computer notebooks, and it can charge it wirelessly.
So, the direction is good. The computer, you need to be careful about the amount of power you can transfer. One of my former students is one of the gurus of wireless power. And so if you look at Josh Smith, he's done lots of versions of sending power wirelessly. Let's see. So he has, let's see, he has lots of versions of, like, this is lighting up a light bulb at a distance, and a number of research papers on how to do it. And so he's transferring lots of power, watts of power. But
Nice.
it's a fairly ambitious thing. And so one direction would be to make something along these lines that can do large amounts of power. Now, so your project raises a question I can't answer, which is, I don't know what the standard is for like a cell phone for wireless power. I've never looked at that. I don't know if anybody listening has. So I don't know if it's just a frequency or if there's some encoding or modulation.
So I tried to figure out how it works. So like about 1 kilohertz the frequency. So about transmitting 4.8 volts. And I think to make a lot of coils, but little, so it can transmit several devices.
So there's a bunch of things in the sentence you said you'll have to work on. So first of all, the coupling is by magnetic fields typically, not electric field, which means what you care about is the current, not the voltage. And so you have to figure out how much current you're pushing. And so there's a week when we're going to cover power electronics, where we'll cover how to switch large amounts of current. Now, you need a lot of coil turns. So the strength of the magnetic field is a function of the number of turns. And so you'll probably want to use magnet wire to make a fine coil with many turns. What limits the number of turns is the inductance, which is how fast you can switch it. But before you worry about small coils, on my desk, I have a wireless charger here, and the reason it's this size is for them to fit in enough turns to get enough magnetic flux.
Yes.
So in the spirit of spiral development, the first thing I would do is, just worry about getting one of these working. And, if you get beyond that, make more than one. But it's an interesting question because, again, I've never looked at the standard for phone wireless charging. And so it would be interesting to reproduce that. And again, just for the physics of it, Josh has written a lot of papers about how this works that can cover, just background for what's going on.
Okay, I will look at it.
Okay.
Thank you.
Good. Okay.
Hi, Neil. Salam is here.
Okay. Salam, tell us about yourself.
Hello, my name is Salim Al-Marri. I'm a graduate I'm currently studying electrical engineering, master's in electrical engineering at Rochester's Institute of Technology. I'm doing controls, and I have worked, I'm a member in Emirates Robotic Club. We've worked on numerous projects, building drones from scratch. This is me throwing the drone, giving it a push. It was an autonomous flight. I don't know if it is called auto takeoff, but it is like that. This is also the team. So we've worked on various projects when we were in university, but once I graduated, I really stopped working at anything. So then I decided to join FabLab so I can be back with more expertise and use my background in this.
Good. So how did you do getting set up this week?
Okay, this week I've worked on Git, brackets. I've made some modifications on CSS, minor ones.
Just to catch up,
just to be
again,
sure.
brackets is another, there are a number of these. They've really matured. Brackets is another one of these nice editors with workflows. Okay.
Yeah. So to get basically started, I tried to modify CSS, and I added Prettify to, rather than putting a picture of anything, I can just put the code nicely so the other students who would like to apply what I'm using can easily copy it and paste it. I've also tried rotating the image, but there was really another way of doing that, which was way easier, rotating it from Windows.
Yeah. CSS has matured, so let me see if I can find some simple examples. You can do, let's see, I'm looking for something in real time. CSS, you can actually do full 3D graphics just in CSS because it has 3D transforms. So even before we get to GL, you can do CSS 3D graphics. It's very powerful.
Also, I tried to add an indent to the text because I'm working on a thesis, and the standard is we need to put an indent at the beginning of each paragraph. Yeah. So it also took me a while to figure it out how to do it on CSS in the correct way.
Yeah. Well, also, you can also do a lot of that in line. If we go to just, let's see, we go to this page, if Control U opens up, and if you look at this, I just put in a div that gives me margins. And so, CSS doesn't have to be in an external CSS file. You can do all of this in line for a little thing like that.
And also whatever I've done, I was able to use Git to push it on the website. There were the steps, obviously the status, add all, and so on. I got really curious about the SSH because we merely just applied the code, but I really had to ask the mentors here, what is it really about? Then I understood that it is, instead of logging in with a username and password, I can use the SSH, which was more efficient.
Yeah, well, it's two things. It's replacing the need for the password, but crucially, it's encrypting. And so SSH lets you move information over the internet in an encrypted way. Is the other key thing that it's doing.
Okay, I believe that's all I have.
Okay, but now what about final project? Do you have a project page?
Yes, it's on home currently, or week one. Yeah, they're the same.
So let me urge everybody. For now, it can be in week one, but start a final project page. And start tracking your final project beyond week one. So what are you looking at doing?
I want to do a smart home automation project. You know, there are lots of ways for a person to open his home garage to park in his car. He can use a wireless key, use a SIM card. I wanted to add a new way, which is a budget way, using the camera to identify the car plate number. I also want to take this chance and see what can I do with machine learning. And if I couldn't do much with machine learning, I will go back to open source programs like OpenALPR and other ones just to get it running.
Sorry, you separated machine learning and open source. There's great open source machine learning frameworks. Now, isn't it a huge vulnerability that anybody can get into your house if they know your license plate?
So this is what my mentor told me, and I'm still figuring out a way to do that. Maybe we can see the car color, maybe. So we're still maybe the PIR, but still, I
Yeah.
need to figure out something.
Yeah. What you might do is have the equivalent of a password. Have like a little image in your dashboard that's like a QR code that you can change periodically. So later in the semester, I'll just briefly touch on some of the machine learning frameworks. I will cover how to do basic vision systems. And so for the final project, you could have almost any vision system, but then have the vision system talk to the actuation system. And a good thing for this class would be not to buy the thing that opens the garage, but you should be able to make that. So making the motors, the motor controllers, the mechanisms to move the garage, all of that would be good stuff in the class.
So one more thing I was looking into the project is that I wanted to make it as cheaply as possible, because there are many ambitious home automation projects that are out there, but you can't find something that is within the budget of a household to be implemented.
So yeah, again, we're going to cover motion systems, motor control, all of that. Danielle is a great resource. And then something I'll cover in the Sensor Week is how to use just HTML and do image processing. So JavaScript has really radically improved in performance. And so this is a vision system just running in a web page using HTML5 to do the basic video. And then I can point you at some of the ways to parse the image as inputs to it. Okay, so that'll all be fine. Okay, thank you, Salam.
Thank you.
Where is La Lab, Elvira? Oh, Suriname. Are you on, Suriname?
Yes, we're on.
Okay, good.
Yes.
So just to remind everybody else, Suriname is there. And tell us about yourself.
So, my name is Elvira Rajesh, and yes, I'm a student business economics, and yes,
So tell us about.
I would participate in. I'm participating in FabAcademy 2009.
So it says you're a distance education officer. Talk about that.
My department, we have students that work far away from where they need to study. So my department, we how do you say it? We yes, we implemented distance education so students can follow their studies online.
Good. One of the programs emerging in Fab Academy is Fab Academy X. So we have this global campus, but also creating local versions around the hubs. And so that a potential direction in the future is, well, La Lab is participating globally to also fan it out locally. And we'll be describing more about that as that progresses. So why are you taking Fab Academy?
So until recently, I actually didn't know about Fab Academy, but my employer asked me to participate.
Okay.
And when I saw the modules, the courses, I was very interested in especially 2D and 3D design.
Good. Okay. So then if we go back to how did you do getting set up this week?
So yes, I followed a Git tutorial, and I used Git Bash to. I only used Git Bash to get my SSH key, but I
Good.
created a website in GitLab. So I
Okay.
didn't use Git Bash to, how do you say
Okay.
it? To
Yeah. So it's not Git Bash, it's just Bash. So, just as a note, you should know Bash is much more than a terminal. It's actually a whole programming environment. Sometimes I write programs that just simply run in the terminal. It's a terminal for commands, but it's actually a whole computing environment right in the terminal. There's a huge amount you can do right from the terminal. Okay, so looks like that all works. And then what about your final project? What do you want to do?
so right now I just I was thinking about creating something as a lamp with an option to charge your phone,
Okay.
and this all will be put in a kind of like a miniature furniture. In a miniature furniture kind of way. I saw a photo of furniture made of pellets, and I liked it very much. So I was thinking about making something a little bit of a chair with a table, but in the table it will be a lamp, and you will have the option to charge your phone.
Okay. That's fine. And if you plan ahead, you can use each week's assignment to do that. Each will contribute. And this is a good example for the issue trackers. So, from Armenia, we heard about somebody looking at wireless phone charging. You can talk directly, but by all means, use the issue trackers to share experience. So you could do a wired charger, or you could do a wireless one, and you can use the global issue trackers to share experience as people learn about that. But that's a fine scale for a project. Okay, good. Thank you. Santa Chiara, Marco. Let's see. Diori, do you know about Marco? No response from Marco or Fiori. I'll make a note. Marco from Santa Chiara. Lorain County, Bridget O'Neill.
Unmute.
Hi, I'm Bridget.
Any relation to Paul?
Yes, there is. My dad's right here too. Say hi.
Hi, Neil.
Hi. By way of introducing Bridget, Paul, can you introduce yourself?
Yeah, my name is Paul O'Neill. I'm a graduate of last year, and I'm a winemaker here in Hinckley, Ohio, where it's -5 degrees Fahrenheit.
How are your vines doing?
They're getting clobbered right now.
Okay. And so, Bridget, I take it you're related to Paul?
I am.
Okay.
So I had a little bit of trouble with Git earlier, especially
Well, first,
since...
not yet Git.
Oh.
Sorry, Bridget, go back. Tell us about yourself.
Well, I'm a student at Western Reserve Academy in Hudson, Ohio. They still have school right now, but I don't have to go because I live 30 minutes away from my school. So everyone else is just kind of freezing in the -5-degree weather. I take digital engineering. Well, I took that already, and I'm taking advanced digital engineering with Mr. Gerber, who graduated in 2016. So
Nice.
that's always a really fun class. And
Nice.
yeah.
And why do you want to do Fab Academy?
Well, I really want to learn more about digital engineering. Oh, what?
Yeah, no, go ahead. That's exact. Go ahead. Yep.
I want to learn more about digital engineering and that sort of aspect, and I have a little bit more experience from when I was younger making different alarm systems and using IoT for fire alarms and making them communicate with each other. That was a fun project, and, well, I know this is kind of a cop-out too, but my dad did it, and I really want to, like, do the same thing, because I remember seeing him during the lectures and meetings, and that always seemed like a really fun experience, and being able to do all these projects. And then also, we had a class freshman year where we had to learn how to use all the stuff that Mr. Gerber taught, and a lot of the students there were really uninspired, and most everyone at least passed with a B or B-, and it was kind of upsetting because I really like this stuff, and I know a lot of younger people might not like it, but they all really love the final product, which is why I kind of want to help more younger people to become inspired to actually make their new technology and help drive forward our technology because everything is going to become obsolete in 5 years, so who's going to make it?
That's great. Yeah. Paul, can you introduce Bridget to Sherry for the Scopes DF project, which is developing Maker K-12 education? I think Bridget would be a good resource for them for that.
Sure.
Yep.
It'd be my pleasure.
Okay, so then how did you do on Git?
So I had a little bit of trouble logging in, especially since, well, I haven't gotten to project management yet because of my trouble with Git. I have a few screenshots of the trouble I had with Git with not being able to log in and having my username, my email not being confirmed. I had to search through all my email addresses again because when you're put on the watch part of the Fab Academy notifications, your email kind of gets blown up, and every time I tried resetting my password, that was another email, and so I went through all my emails again and confirmed my email address, and then I was able to actually get on and start doing my project. I know some other people in the independent nodes are still having some trouble, and
So, sorry,
yeah.
Is there an explanation for what was the problem you had getting on the site?
So I think the first time I tried confirming my email through the email that was sent to me, I don't think it completely went through. So then I had to go back again through all the emails and then confirm through that one email that was sent to me. And yeah.
Okay, I just want to make sure if anybody's having trouble getting on the GitLab site, reach out to the central coordination. At this point, it's very important everybody be on that. Okay, right. But it's working for you now?
Yes.
Okay, good. So it sounds like you haven't gotten up to trying to do it locally. You're editing through the site?
Yeah, I'm just editing through the site. I haven't used any GUIs yet, so.
Yeah. So for the just for next week, a number of people we've seen have written their tutorials on how to get set up to do it locally. And very quickly, you want to be able to edit locally, not just through the site. Okay. And so what's your final project?
So, at Western Reserve, I'm on the JV volleyball team, which we really need to work on our serving, but we don't exactly have all the time. And there's a lot of time that goes into picking up all the balls that you serve over the net or don't serve because sometimes you mess up a lot. And so I want to make a kind of mat for volleyball serving to cut down on that time that is spent going over and picking up balls and putting them all in the basket again and then serving them, and also to track speed and to see if it actually goes over the net. So my final project would probably be best suited for those types of people. But when I was like mapping out my project, I found that I had a lot of issues with how I would hook it up and if it would be strong enough to withstand the force of a volleyball, since there's a lot of speed.
Sorry,
and
let me catch up. Is
okay, sorry.
Is the idea that you're serving the ball into the mat and it bounces off?
Yes.
Okay, and then you want to measure the force of the ball bouncing off the net, off the mat?
Mhm.
Okay. Yeah, you'll be able to do that. In the input device week.
Yeah, I looked at the execution for that one.
Yeah, I covered my favorite sensor, which is capacity. So here are 2 electrodes. And so just now it jumped up because I put a material between them. And right now they're spread out. But what you can do for something like this is if you have conceptually there's some subtleties. So if you have one electrode you're transmitting into, one that you're listening to, and then you put this whole thing in an elastomer, in a foam, when the ball hits, this will bend and you'll get a big spike in the capacitive signal. And so you can make a force sensor by having capacitive plates in a foam. And then, it can be very robust because it's just this elastomer. So that would be a reasonable thing to try to do.
Mm-hmm. That's kind of what I was thinking about with using styrofoam as the back, and then I would have a sensor here, and then I would have the different plates. So when you pressed it down, then it kind of compress like keys on a keyboard, and then hit the styrofoam, and then you'd be able to
but it wouldn't be styrofoam because you need an elastomer, and so in the molding and casting week, we'll cover a number of moldable foams. So a number of them come from Smooth On, and you can get urethane rubbers that you can cast where you can tune the stiffness that are for a material, a stress strain curve is how much you push and how much it responds. And so a spring, it's linear. It goes up and down like that. For something like this, what you don't want is hysteresis. So when you push, it doesn't come back to the same place. And you don't want the material to be damaged. So you want it to stay in a linear elastic limit. And so one possibility is elastomers, like urethanes from Smooth On. And another is an industrial supplier I use is a McMaster car. And if you look for foams and rubbers, they have a whole product line of all different foams and rubber sheets. And so you can pick out a material, and you have to experiment about one that's like the right thickness and the right stiffness. But getting a few layers of that with the electrodes, making that into an assembly, and then getting the data out is a good project. And so for spirals, initially make a little one for your finger, then make a bigger one, then make it stronger. But that's a good project.
All right, thank you.
Okay, good. Glad you're doing this. By the way, just before we leave, Paul, how did your final project end up in your winery? If we go back to, let's see, prior years, 2018, students all O'Neill. And then your final project. So how has that ended up for the winery?
I'm still using the prototype. There was a fellow out in Erie, Pennsylvania, who's an engineer at General Electric, who wants to work with me on developing it further, and we're still talking.
Just for the people listening, explain the project.
The project is a gas sensor for winemaking, and what it does, it monitors the oxygen content in a wine tank. Oxygen is bad for wine. It makes it oxidized and not taste well. So the purpose of the project was to have a way of evacuating the oxygen and knowing when the oxygen is eliminated from a wine tank, whether it's a fermenter or a storage tank.
Okay, good. Okay, Fiore or Marco from Santa Chiara? Nope, still miss. AKGEC, Ahmad? AGEC, Ahmad Ali. Okay, I'll leave that up.
Hello.
Are you there, AKGEC?
Hello. Yeah, I'm here.
Okay, good. Tell us about yourself.
So my name is Ahmed. I am a final year student of AKGEC, studying electronics and communication, and I'm in a robotics member of my college club, and I've been into robotics for about 2 years, making projects for my college. The idea of Fab Lab was seeing my seniors doing it, so that's why I'm here making things.
Okay, good. How did you do this week? Yeah, this looks like a fun framework.
Yeah, actually, I spent a lot of time in editing the template. It took a lot of time to download and get used to HTML, CSS, and Bootstrap.
So it looks like you don't have a page for this week yet.
Yeah, this week I just pushed my report today only, 4 hours earlier, and I've made it in my local repository. I was having problem with Git, and so I just went to my instructor, and he made me clear things about Git. So my second week is not still pushed yet.
Okay. Viral development applies each week. And so it's very important, like in this example, you don't try to push in the last day before class, but you get set up early in the week to be able to push. And something like that will be true each week. What kind of framework are you using to do this site?
It's HTML and CSS.
Okay. But did you write the framework, or where did it come from?
No. I downloaded it from polomo.com. And then I edited via Sublime Text.
Okay. And then final project, what do you want to do?
Yeah, actually, I wanted a review of yours on this project. I have 2 ideas in my mind regarding my final project. The first idea is making a smart trolley in which we will have a barcode sensor or an RFID sensor that will sense the product's barcode and will give the information related to it, like the discount, the price, and various other things. And my card will have an arrays of IR or ultrasonic, which will count the number of products going in my cart, so that I can physically see on my LCD that how much product I am just putting in my cart. And it will be communicated wirelessly by the billing counter. As soon as I push one button, my cart will be closed from the top and it will get opened from the bottom, and the person can just take the packet and move out from the shopping mart.
Okay.
This is my first.
And again, before I comment on it, tell me why you want to do that project.
Because I'm from a business family background, and like the online fashion has made people too lazy to go out of their houses and buy stuffs. So what I feel like people should move out and buy stuffs from local markets, because my father is also a local market. So I'm just targeting people to come and buy stuffs from supermarkets, so that using the technology that people come and.
Right. But the question is, are people limited in going to the store because the checkout, or is it because the store isn't interesting enough? I mean, a different kind of project would be to make something that makes people excited to be in the store.
If technology will be added in stores like in local markets, people will be excited to use that tech. So they'll try to buy things in the local market rather than just purchasing it online, Amazon or Flipkart in India.
Okay. So, and then what is the other project idea?
The other project is kind of personally related to me. I'm a rider. I ride a bike.
Okay.
In India, in hot and humid days, nobody wants to wear a helmet, a bike helmet.
Okay.
So people compromise their safety for sake of getting fresh air. So I'm like thinking to devise a smart helmet system which will consist a fan controller inside of it, and it will have vents that will provide air to the rider. As well as I was thinking to add on a heads-up display like one you have in Iron Man, which will show which will have sensors like accelerometer, which will show the speed and the navigation system to the rider. It will be an add-on to my. Okay.
So a general comment is both of these are really multiple projects. Each is multiple projects in a project. And also both of these are the subject of businesses with lots of investment. And so within this class, you won't be able to do all of either of these projects. So you need to focus the scope a bit. And so, making a cart that reads the products you could do, a lot of the work to make that one successful will be integrating into the store information systems. I think for scope, just doing the heat transfer in the helmet is already a lot. And so we'll cover a number of ways to make the helmet, and then having the power electronics to run the fan and measuring the temperature. And then you'll need to experiment with systems for the airflow. Just the thermal management in the helmet is already plenty for a project. So either of these are possible, but I would steer you towards reducing the scope a bit. The goal of the project is to integrate the skills. You can't do the work of a whole startup business of 100 people in one project. So you'll need to tighten the focus.
Yeah. I understand. I understand that.
Okay. But I think of those, I think, the store is a little non-trivial because it involves a bunch of systems you need to integrate with. I think thermal management in the helmet is a nice exercise because you need to measure the temperature. You need to, introduce ways to modulate the temperature. You'll need to experiment with temperature control, like, do you have liquid moving in the helmet? Do you move air through it? Do you have layers internally? And there's a lot of interesting work just in the thermal management for the helmet, and then finally integrating that. I think that's a nice scope, and that has the shopping cart doesn't. A lot of work has gone into how you make stores you can just walk out of. And there is research, but it's pretty advanced, things like RF channel sharing. I think there's a number of interesting questions about how to make effective thermal management in the helmet that are a good scope for the scale of the class.
Okay. So I was thinking to print the whole helmet via 3D printer, or just to take a helmet and add on things to thermal.
Yeah, neither. The goal in one of the goals in the final project is make rather than buy. You should only buy what you can't make. The 3D printed helmet will be heavy and have poor material properties. So one of the ways you can make the helmet is when we cover molding and casting, we'll make tooling to cast the helmet. And closely related to that is we'll talk about composites, where you lay up a composite helmet. But, you know, an important part of this project will be learning to make the helmet, and we'll cover a number of ways to do it. And by doing it that way, then you'll have much finer grained control over the integration in the helmet. And so making the helmet is a challenge, but it's a good one for the class. Okay.
Okay, thank you. I'll get to homework. I'll do my homework on it.
Okay. Okay, good. Let's see. Pamela is talking. Are you trying to talk to us or just not muted? Let's see. We're getting audio from Pamela Kiyomogisha. Okay, one last try for Marco or Fiore. No. Okay, then let's see. Pamela needs to mute, and it's up to quarter after. So let's go to anybody who had either questions or interesting projects this week. Did anybody make websites that are a bit different from ones we've seen? Anybody who wants to share what you did this week?
Hello, Nim?
Yep.
Hello.
Go ahead.
Hello, my name is Babken. I'm from Dilijan. I'm from Yerevan, Armenia. I work as a teacher at elementary school, at a private school. I teach.
You're Babken? Okay.
Yes.
Okay,
yes.
So, ooh, this is a nice site. So talk about your site.
I actually used the same HTML5 app templates that majority use, but I used two templates, one for my weekly assignments and one for my homepage. I wanted to just to discuss. I wanted you to have a feedback from you.
Yeah.
Okay.
Okay. Yeah.
About my final projects and about my website.
Okay. So yeah, website looks lovely. Yeah, and then image sizes we'll talk about. Yeah, what's the background image on your site?
Yeah, it's actually from our. I wrote it in my website. It's very old, illustrative painting from Armenian Kingdom of Kilikia. Yeah, and
Okay.
I have the link. I have stated the source for the. And it was illustrated by Horace Roslin. He's a very known illustrator.
Okay, nice. So did you have a final project question?
Yeah, okay. So my final project is about carving, is about building a mobile CNC machine that would carve on ready walls. When we have a lot of ready walls from roof, it's a relative soft rock that is and not just ready panels, but walls that are made from bricks.
Okay, yeah. Okay,
And I have
so you,
a proposal
yep.
for final project that is about smart classrooms, building a chair that takes attendance notes from each student.
You could do either. Which are you more excited about?
I'm excited about both, but actually we talked with Ohad and he thinks that the first one is better because it somehow reflects our cultural heritage that we have in Armenia. Stone carving is very old tradition in Armenia, and we have so-called khachkars that are carved rocks, and we have a lot of them all over Armenia.
Yeah, so I like that project. There are a few ways you could do it. So first of all, one note is this is potentially two projects. One project is the large format motion system that can move over the wall. Another is the machining system that can mill the wall. And for the final projects, another important piece of the guidance is projects can be separate or joint, but if they're joint, you need to show the parts separately. And so to take in this example, there's one whole project of the thing that's milling the wall, the end effector, and there's another whole project on the motion system. And potentially that's two separate projects. And so if anybody listening anywhere in the world is interested, you could potentially collaborate. So one version of this would be to be a large gantry, as you've shown. One question is if it's really easy to mill the tough stone. I don't know if this would be crazy or not. There have been many versions of this project where you have 10 strings or tendons going to motors, and then you make a motion system and to move over a space. Now, first of all, if you do just what's in this picture, it's terrible, because if you only have 2 strings, it jiggles. And so the first thing you need to do is you really need 3 or 4. You need to over constrain it. But if you did something like this, you could position much more easily over the wall. It wouldn't be very stiff in the z-axis. But if the tough stone is really easy to mill, you might be able to make a version of this where these are heavier. So either like a metal wire, or those could be rods that go in and out. But something like the wall drawbot turned into a light milling machine, I think would be a very interesting direction.
Okay. That's what Olga told me yesterday.
Yeah, and so let's see, McMaster car. There's various names for it, but there's let's see, there's a name for, I forget what McMaster calls it, but there's heavy duty braided metal sort of rope made out of steel for heavy, for much heavier loads, to either make stronger tendons, or rather than wrapping it around a spool, you could just have, rigid posts that go in and out. So like, one version of that could be like a rack and pinion. Let's see, if we look at Jens Evik Fellas Bergstedt, Jens is one of the gurus in the Fab Lab network for machine building. And he makes, so what you're looking at here is a rack and pinion where he made this in his lab. And we'll cover this later in machine building. He has a nice family of machines that make these rack and pinions.
I'm sorry, could you please repeat his name?
Jens Divek. So if just in the recording of the class, I'm at Jens Divek Felles Werkstatt. And it's just, if you search for Jens Fab Lab Norway, it'll take you right to that page.
Okay.
Okay. And he's making, this is a fun sequence of a shopbot made that machine, which made this machine, which made this machine. And for the motion systems, he makes his own rack and pinions. I have a student, Jake Reed, who has a site, Open Assemblies, where it's a slightly different approach. Where what Jake does is he uses the bearings from roller skates, and then he uses these bands rather than the rack and pinion. But this is another version of making your own axes for the motion system.
I love this.
Yeah.
Thank you very much.
Yeah. And so we'll cover lots of ways to do those when we get up to machine building. Okay. Who else has interesting successes or failures?
Hello.
Kaipur, go ahead. Okay, we'll do Kaipur and then Vegan Ashram. Kaipur, go ahead.
Lodro.
Yeah.
So I have a question regarding my final project.
Yeah.
It's
so first of
Dishan
all,
Ahmed.
okay, go ahead. What's your name?
Dishan Ahmed Lodro. Second last. Last.
Okay. Yeah. Got it. Okay. Yeah.
Okay. So I have a question regarding my final project.
Yeah.
Basically, I got an idea from a previous candidate, Fab candidate. It was about crystal structure digital cube. So it is mentioned in my assignment week 1. In assignment section.
Yeah.
I
understand. I'm going back to it. Let's see.
Yes.
Something's wrong with the website. I can't. When I go to assignment, I get contact me. I can't click on assignments.
Okay. Let me tell you. I want to.
Okay. Oh no, there I got it. Okay. Yeah, go ahead.
Okay. I want to make a digital cube which shall print all the cubic crystal structures. In that means the cubic structure which are found in nanotechnology. So I was really interested. I am really interested in this project, and to add some extra features. I want to add some image processing, like detect some materials and print the structure of that material. And second thing is that I want to detect the voice of any person or image of any person.
Sorry, let me interrupt. Sorry, I'm going to interrupt for a moment. Let me explain to everybody. This open time at the end of the class isn't just for final project reviews. There are hundreds of students, and we'll work through the random generator. The real goal of this open time is not for final project questions, but to go over the work of that week. And so each week I want to cover who had successes, who had failures, lessons from the week. So let me respond to you on this one. But the goal of this time is not for lots of final project questions. It's to talk through that week's work. This is a good direction. I think something that would be really interesting is crystallographic groups. So the heart of crystallography is something that's really important but hard to learn. There's a crystallographic notation, and there's a fixed set of all possible crystallographic groups of local organization of a material. And so something that could let you visualize the crystallographic groups physically and tell you what they are, and then tell you what materials have that group, would be really interesting. So a 3D version of the crystallographic group display, I think, would be a really nice project. So like turning this into a 3D display. A number of people have made lattices of LEDs, and that'll be straightforward. But connecting it to this crystallographic groups would be really interesting. Okay, we're almost out of time. Let me go to, I know Vigyan Ashram wanted to say something, but once again, this time isn't just for final project questions, it's to talk about lessons from the week. So Vigyan Ashram, go ahead.
Yes, hello, this is Manoj.
Okay.
Can you hear me?
Yep, go ahead.
Okay, so I have a bachelor's in mechanical engineering and master's in entrepreneurship.
Okay.
And before Fab Academy, I was working as a business developer.
Yep.
My goal is to find some innovative product and start my own venture.
Okay, but again, let's not do the whole random review. We only have a few minutes left. What's your question or comment?
Yeah, I wanted to show my website. It's made from React framework.
Okay, let me explain to everybody. Vigyan Ashram we call Fab Lab 0. Fab Lab 1 was in Boston, but I visited Vigyan Ashram many years ago before Fab Labs even started, and the idea really grew out of working with Vigyan Ashram. Callbag is really where I learned about the opportunity and the need for what became Fab Labs. And so that's why this is Fab Lab 0. Okay, so how did you do your site?
So I have used React framework,
Okay.
React framework that is used for designing front-end websites. It's a JavaScript library.
Yep.
So I have used Material UI components. Like React has this feature of creating custom components. So I have built using Material UI this whole website.
So just explain Material UI.
Yes, Material UI is like based on Google's material design. So they have created components of React based on material design, and all the things which you see here are components. Just like HTML tag, we can create custom tags. Like say for example, Manoj. So I can create curly brackets. I can have Manoj as a tag and use like each component I can create and place it wherever I want.
This
so
is beautiful.
There is a parent.
Good. This is exactly what this chunk of time is for. It's sharing stuff relevant to the week. This is a lovely site. And if anybody else looking at this admires Manoj's site, shamelessly copy it, just credit where it came from. But it looks like you're nicely set up for the semester.
Yes. Fine. I have to talk about my final project idea. So I have mentioned 3 project ideas in that one, principles and practice. You can click on that. The exercise 1, yes. So you can click on that and to view the idea. So first project, I'm thinking to create a electronic nose for detecting pesticides. And second is a heat container for making for fermentation. And there I'm trying to cost optimize for a household. And third one is bookization, and I want to do it for the Wikipedia community. In Vigyan Ashram, we have a lot of contributors in Wikipedia, and they do scan books manually, so it could be automated.
Yeah. All of those are plausible. Given what I know about vegan ashram, the controlled fermentation is probably the most relevant for vegan ashram, just for the food production. But I mean, we can talk more. Any of these are possible. One caution on the Peltier. Peltier does require a fair amount of pressure of power, and so I would, along with the Peltier, I would look at just conduction and convection and evaporation. And so, depending on the temperature of the day and the humidity, there's a number of ways to regulate temperature that might be more power efficient than the Peltier.
Okay. Actually, the idea of using Peltier was to create a low-cost system which can heat as well as sense the temperature. So
No,
let's see.
well, you can heat and sensing the temperature is easy. You can heat and cool with the Peltier. But once again, you do need to look at the power budget for the power available versus the watts of cooling from the Peltier. But let me just, once again, the last part of class is not to just keep doing final project reviews, just like you showed with your React framework and the material. Yeah. Sorry, let me talk. We're almost out of time. The last part of the class is to talk through lessons relevant to the week. What succeeded, what failed, what might come next. Okay. So with that, we're up to 10:30. Last word from Vegan Ashram.
Okay, if you want to, you can look at my project management, like the Git and the website details, or we can wrap up otherwise. Yes.
Just to say, this is a beautiful site and it's beautifully documented. And this is great tutorial material. And anybody having Git issues, this looks like a great guide to start. So nicely done site. So we're up to 10:30. So 15-minute bio break, and then we'll start in on design tools.
Okay, sir.
Recording has stopped.
So now we really begin. The first week was intro to what this is all about. Second week is getting you set up with version control and web development. This week, we finally really start in. So this week is design tools. Then, once again, no recitation. Next week, we start in on Fab Machine. So today's all about design. The assignment for this week is model your final project. And by model, I mean as many different ways as possible. So raster, vector, 2D, 3D, rendering, animation, simulation. Make a computerized representation of your final project and put it on the class site. Now, your final project doesn't have to be settled. It could change over time. So pick a final project, and the real goal this week is to learn about the different design tools and pick the ones that you're going to be using. So lots to cover. there's no right answer, and I'll give you lots of options, and I'm going to cover many different tools, and you'll find you'll use a range of them. It's like an artist's workbench might have many different pens and brushes. In the same way, there's many different tools you'll use, not a single one. So first we'll look at 2D drawing, then we'll look at 3D CAD. So to start in 2D, you could just work by hand. This is a student who did something really amusing. I don't really recommend, but it's impressive. You could draw by hand and scan it into the computer. And so he made a whole circuit board. He just looked at the components, and his eye was so good. He looked at the components. He drew the circuit board with a pen and paper. He scanned it into a computer and then fabricated it. And so we'll show you how to fabricate right from an image. Hard to do precisely, but very expressive. GIMP is freely available, cross-platform, a very powerful pixel editing program. So when you work in GIMP, if you draw something, if you zoom in enough, what you'll see is you're representing things as individual dots, as individual pixels. So GIMP lets you paint, it lets you edit images, and it is a design tool because we're going to cover how to go from an image to all the fabrication tools. So once you have an image, you could laser cut the boundary, you could cut the intensity of the laser, you could machine the image. And so this is good for things where you need flowing expressive designs and you need single pixel images. So GIMP is powerful, freely available, cross-platform. I use it all the time. The commercial most popular tool is Adobe Photoshop, which is less extensible in some ways than GIMP. In many ways, it's more powerful than GIMP, and it's also, but it's a paid tool you buy or subscribe to. Popular with people who do this for a living. I do a great deal in GIMP. A neat tool to know is MyPaint. So in class, when I've been making these sketches, I'm using MyPaint. And what that lets you do is it lets you first pick the material you're on. Is it fabric? Is it paper? And then it lets you pick the kind of brush you're using. And it has many types of brushes. And so it emulates drawing on a material. And so it's a really nice drawing painting tool. And that's what I use for the illustrations in class. And now we get to these tools. This is going to be very important. ImageMagick is a suite of tools. As sometimes happens in open source projects, there was a split, and so there's Graphics Magic. These have diverged slightly for our purposes, though they're equivalent. Just they didn't agree. This is a suite of tools to process images, and it can convert anything to anything. And so if I so convert is a utility. And if I convert minus list format, these are all of the formats it knows how to read and write. So any one of those, it can read in and it can write out. Every possible kind of image format. So you can convert, you can change formats like JPEGs to PNGs. You can convert vector to raster. But now here are two really important ones. When you take a picture with your camera, it could be easily tens of megabytes or more depending on your camera. On your website, the images should be tens to hundreds of kilobytes, so you don't take up much space, and so they load quickly on the web page. And so to do that, you want to resize the image down to web resolution, and you also want to increase the compression. If you're not doing high resolution photo printing, you can compress the image. So this for example, takes an image, it compresses, it increases the quality, and it changes the resolution in just that command line. You could do the whole thing in GIMP. If we, I don't know, take a picture of the Earth, and if I take, let's see, open image in new tab, save images, save that, and then if I go to GIMP, I can open this in a tool like GIMP, and then I can go into the image settings, and I can change the resolution of the image, the size of the image, and if I save the image, I can then adjust the compression of the image. And so by doing all of that, you can reduce your images by like 100 to 1 compared to the camera. But this does it all in one command line.
Neil?
Yep.
Just want to say there's a really great tool, plugin for GIMP, which is called BIMP, B-Y-M-P.
Never heard of it.
B, not V. B. Yeah.
GIMP.
And this does a bit like Image Magic, but inside the GIMP interface. And
nice.
It's batch manipulator tool, really, really great.
Lovely. I've never seen that. I'll add a link to that. Good tip.
Cool.
And yeah, class is interactive. Do speak up, things like that. And then here's a really great utility. So Mogrify is part of that suite, and this is the batch version of what we just saw. There's a GIMP plugin to do. What this will do in one line is take all the images in a directory, and it'll change the quality, and it'll change the size. And so you can just you can do it clicking and dragging, but just with these utilities, you can take all the images for a week in the class, and then you just run that one line, and everything has been compressed and resized to web resolution. So very handy tools. So that's raster. Then comes vector. So Inkscape is, again, freely available cross-platform vector drawing tool. And so if you go into Inkscape, now in Inkscape, if I start drawing and then I zoom in, no matter how much I zoom in, there's just lines. There's no pixels because Inkscape is drawing geometrical objects, circles and lines. You can't really do CAD, but you can sort of do CAD. So what I'll show in this example is, to understand that example, in the laser cutting week, your assignment is going to be to make a press fit construction kit. And an example of that is this. And so to make these parts, each part has a cutout, but the size of the cutout depends on the thickness of the cardboard. So if you change your cardboard, you need to change all of those slots. And so how do you propagate the slots through the design? Well, here's a simple way GIMP can do it. So what I'll do here is I'll draw a shape, then I'm going to draw another shape, and then I'm going to do what's called a Boolean operation, where I subtract a shape from a shape. And that's a very important CAD function, is logic on shapes. So now I'll do that again. I'll make that a different color. But now what I'm going to do is I'm going to, so first I'll align the objects. Then I'm going to take this object, and instead of copying it, I'm going to clone it. And a clone creates a linked copy. And so with the clone, I can align that. And now if I take that object and I change the original one, the clone changes. And so that was a really simple way of, I'm going to show you much better ways, but let's see, somebody is asking on the chat to do something on my PC screen. I'm not sure what you're asking for. That's a simple way to make a cutout, and when you change one cutout, the other cutouts change. It's not really full-blown CAD. It's just a simple example. So Inkscape is freely available, nice tool for vector drawing, where you don't want pixels, but you want shapes like circles and squares and curves. Yeah, as a reminder, for BlueJeans, there's a slider that controls the relative size of my screen versus the video screen. You control that from the client. Illustrator is to Inkscape as Photoshop is to GIMP. This is a paid, powerful vector drawing tool popular with graphics professionals. And then we get to a really interesting tool. The main problem with FreeCAD is the name. The name makes it sound simple and crude. FreeCAD is an open source CAD tool that just year by year started pretty simple, but keeps getting better and better, and it's become really powerful. So FreeCAD includes both 2D and 3D drawing. So now I'm going to redo in FreeCAD what I did in GIMP, but in a much more powerful way. So here I am in FreeCAD. There are workbenches. And so I'm going to pick a workbench called Sketcher, which is for 2D drawing. I'm going to add a sketch. So now this is like where I was in Inkscape, where I'm making a drawing. So now I'm going to make a square. And now I'm going to make some cutouts in the square. Okay, but what's very different here is this drawing tool is a constraint solver. And so I don't just draw what I want. I can express relationships in the drawing. So it's a much more powerful concept. So the first thing I'm going to do is I'm going to trim the intersections. So I don't need those. So I'm trimming where those lines meet. And then as I'm doing this, you'll see these little red things are appearing. And those red things cluttering the screen are constraints. They say like a line is horizontal, or a line is perpendicular, or it meets at a point. But you can express constraints. So if I move that point, nothing happens. I just move the point. So what I'm doing right now is I'm picking 3 segments, and then I'm going to pick a constraint. And I'm going to say those should be the same length. So now if I move a point, you see all 3 move at the same time because they're constrained. Now I'll pick those 2, and I'll make them the same length. So now those move together. And then I'll make those the same length. So now if I move the point, it stays centered and they all move together. Then I can dimension. So I'm going to assign a dimension to that. And then I'll assign a dimension to that. So now if I go in and I edit, well, let's see, oh, right, before I do that, so now I have my sketch. Now I'm going to promote the sketch from 2D into 3D. So I'll go into a part tool bench and I'll extrude my 2D sketch into 3D and turn it into an object. So there's my object. Now I'll show you a more advanced thing you can do with the sketching, which is, here's a 3D object I'm starting with. But what I can do is I can take a part of that object and I can put a sketch right on that object. And so I'm going to put a circle here. And then I'm going to pull in part of the edge. So I'm going to say I want to use that edge in my sketch. And then I'm going to say I want to control the distance from the edge. And here, I'll just do a little more work. I'll make an object. I'll trim it. And then I can take the sketch I did in 2D on a 3D object and turn that back into 3D. And then I'm going to cut this out of the object. So I'll take those two objects. Now I'll do a 3D Boolean, and I'll take that out of it. And so I drew in 2D on the object, and I drilled into it. So this core capability of constraint solving is much more powerful for 2D drawing. So you can have a single parameter for the slot size and use that everywhere in your drawing. And so FreeCAD is a nice, freely available cross-platform tool that has a very powerful 2D constraint solver. So that's in 2D. 3D is a much bigger universe. This is a link to a thesis from a former student, now at Formlabs, on CAD geometry, and his thesis has a good background on how to represent geometry. So there's a number of terms to learn to draw in 3D. Constructive solid geometry, or CSG, is the ability to do logic on shapes. So you can add two shapes or subtract a shape or intersect a shape. Constraint drawing is what I showed, where you don't just make a drawing, but you express relationships in the drawing, things like tangency or distance. Hierarchical drawing is, if you go back to the cutout slot example, you might design a slot, and we're going to cover the joints are actually very complex. And then you reuse the joint many times over. So a hierarchical design is one where you design a thing, then you use that thing in the design, then you might use those in designs. And if you can change something, and when you change it, you change many different instances of it. A parametric design is one where you have a single parameter, something like the thickness of cardboard or the stiffness of your material, and you change that parameter and it propagates, and everything in your design changes with the parameter. And then procedural and algorithmic design are where you don't click and drag, you write algorithms, and the algorithms generate the design. So no one design tool does all of those, but those are all they all do versions, but those are all features of things you want in a 3D design tool. Some other terms, boundary representations, or B-reps, are where you represent the surface of the object. And because of limitations in computer performance, that's how CAD started. It's more powerful to represent an object as a solid, not just a surface. Those are called functional representations. Those are becoming more important as computers get more powerful. So I'll show both of those. When you begin, it's a little bit like learning Git. When you begin, you'll do everything in a graphical interface. As you get more proficient, you'll start writing scripts. And much of the most advanced CAD is done with hardware description languages, where you don't click and drag. You actually write a program to describe a shape. And so if you want to design a chip with 1 billion transistors, you can't click 1 billion times. You have to write a program that describes the shape. Then imperative design is where you just design what you want. It sounds obvious. Declarative design is you don't design what you want, you describe what you want the design to do, and the computer figures out how to do what you want. And that's an emerging research area. Generative design is where you write programs that do what you can't do by hand. And many things fall under that, but generative design is used to make all kinds of interesting, funny-looking, complex designs. One use for it is things that you can iterate and replicate. A major use for it is optimization. So let's see, that page I just had, the more advanced tools can search. And so you describe how much you want a part to weigh or what loads you want on it. And then the tool searches over the design space to find ways to meet the design. And finally, what's called MDO is multidisciplinary optimization, is you have a design tool that understands aerodynamics and electrodynamics and heat transfer and structural forces. And it designs not just the structure, but how all those subsystems integrate. So all of those are research areas that are moving into design tools. So to do 3D design, you need to be comfortable with all these different concepts, and we'll show a mix of ways to do them. So to start, excuse me, SketchUp and Tinkercad are really easy to use beginner 3D tools. I don't really recommend them because there's a hard limit in what you can do with them. They're easy to get started, but they don't support the kinds of things I just described. You'll run into a limit pretty quickly. Blender is a really interesting tool. Blender has a, let's see, why don't we go to a Blender gallery. Blender started as a startup in the Netherlands. Started as a startup in the Netherlands. They were doing computer graphics video. They got a lot of money as a startup. The startup didn't work. The founders bought it out. It became a foundation. It's now an open source project. What you see here is all computer generated. So these aren't photographs. This is all computer generated images. And Blender is just finishing a huge rewrite. So Blender is an environment. You can do modeling in it. You can then do very, very powerful rendering. And to make the sort of images I showed you, you need to control optical properties, lighting, material properties. You can then do animation where things move and interact and there's cameras, and then you can make videos out of it. The limitation in Blender is the modeler doesn't have powerful CAD features. So the modeler is really good at expressive organic things. It's not good at CAD style modeling. But even if you use another CAD tool, Blender is a great environment for making photorealistic renderings and animations. And there is a project called Sverchek. And what it aims to do for Blender, and I'll say more about this for Grasshopper, is make Blender parametric with a node editor. And I'll show you more about that when we talk about Grasshopper. So in your suite of tools, I strongly recommend learning Blender. Bit by bit, it's gotten so good, it's increasingly impacting things like Hollywood studios, where lots of production stuff for state-of-the-art computer graphics is done in Blender. And again, it's freely available and cross-platform. So not great for CAD, but really powerful for gorgeous photorealistic modeling. So really worth learning. Rhino is popular with designers and architects. It's a paid tool. Grasshopper, it's not parametric. Grasshopper is a very popular node editor. So Grasshopper lets you make a graph to describe the flow of information to a design and lets you do parametric design in Rhino. So it's very popular for that. Kangaroo is an extension aiming to do constraint solving, popular but paid tools. And then we get to FreeCAD again. So FreeCAD is based at its heart on an engine called Open Cascade, a geometry engine. And once again, it's evolved quite a bit into a really powerful tool. So I'm going to do a video now of 3D design in FreeCAD. So I'm going to start a project. I'm going to add a part to it. And so here's a cube. There are multiple ways you can interact with it. So I'm picking the UI. Here's a sphere. And then with Inkscape, I did a 2D Boolean. So now what I'm going to do is I'm going to position it, and I'm going to do a 3D Boolean. So so I just subtracted the sphere from the cube. But now, crucially, unlike a simpler tool, the cube and sphere are still there. So if you look, the cube and sphere are grayed out because I've now done the Boolean, but they still exist as objects. So now what I'm doing is I'm taking the sphere that looks like it's gone, but it's still there, and I'm going to edit it. And when I edit the sphere, I'll change the cutout. So now what I'm going to do is start doing a more complex operation. So just like the clone in Inkscape, I'm going to take the sphere. I'm going to make a clone of it, which is a linked copy. I'm going to position that. And then I'm going to do a Boolean again. So now I have two cutouts. I have my original sphere and then the clone. And then, as you would expect, I can go to the original sphere, and I change the original sphere, and both cutouts will change because it propagates through the clone. Now, this is the heart of parametric design. So you might have parameters like the thickness of your cardboard or the type of material you're using. So I'm going to add a spreadsheet. And the spreadsheet, I'll say radius, and I'm going to add a field. And so I've got a number there, which can be a formula. And then I'm going to give that a name, that field a name, R. So now I'm going to go back to my drawing, and I'm going to take the size of that sphere, and I'm going to link it to the spreadsheet. So what I just did is I just said the radius of the sphere comes from one of the variables in the spreadsheet. So now if I go to the spreadsheet and I change the formula, and then if I go back and look at the sphere, the spreadsheet controls the dimensions of the thing in my design. And that's a very simple formula, but next week I'll show you a more complex use of a spreadsheet with a formula. Now, a few other things. Here what I'm going to do is I'm going to control how it's rendered. So I just made it 50% transparent so you can see into the object, which is really handy when you're designing. And now I'll link it back to the sketcher I showed you before to show how constraints and 3D design relate. So here I am, I'm going to do the Boolean again. Then I'm going to pick that face, and I'm going to draw on the face. I'm adding a sketch to the face. So here's a circle, and then I'm going to say I want the circle to touch the cutout. So I want those to touch. So I did 3D design to make a cutout. Now I'm making a 2D drawing, but I'm connecting the 2D drawing to the 3D cutout. Now I'm going to extrude that. So I'll take that sketch and I'll extrude it and cut it out. Make it a solid. And then I'll do a Boolean on that. And so now I'm going to do something non-trivial. Now what I'm going to do is I'm going to go to the original sphere. I'm going to change the size of the sphere. And so watch what happens. And so the sphere got bigger, so that circle got smaller. And so when I did that, the sphere data had to go back through the Boolean. Then the Boolean had to go to the constraint solver for the tangency of the circle. And then that circle had to go back through a Boolean to subtract it again. And then all of that is linked. And so just that last little bit, a whole bunch of different steps have to happen in the parts of your design. So that's what a more powerful CAD tool does. And in the coming weeks, I'll show you a number of different examples of more complex spreadsheets and parametric designs and use of that. So once again, FreeCAD has evolved quite a bit. Well, let's see, I don't have it on, let's see, since this is Linux, I can just ask for FreeCAD, so I'll get that installing. And it's well supported on every platform. And so it's a really good, it just keeps getting better and better design tool. Here, I'll show you when it's done opening. So then from Autodesk, there was AutoCAD that I don't recommend for anything new. It's largely historical. There was Inventor, and focus at Autodesk is Fusion. And until recently, a former student from my program at MIT ran that, Eric Wilhelm. Fusion is beautifully integrated. Its real strength is CAD, CAM, and modeling are all nicely integrated in the tool. It's not free or freely available, but Autodesk has a very aggressive education program. And so it is freely available for educational, non-commercial use. They've been very generous in making it available. You do need an identity in their cloud to use it, and you need connection to their cloud to use it. So you can't use it on a deserted island. But it's very popular because it's so beautifully integrated. CAD, CAM, all the steps, modeling are all nicely integrated in it. So here, thanks to the wonder of apt-get, I just installed FreeCAD. I was just going to show you, so let's see, let's see, it's not, let's see, it's not set, okay, here it goes. There we go. It's based around workbenches. So there are all these different workbenches and they keep adding ones. And so this is one for structural modeling, for example. This is one for dealing with point clouds. This is one for dealing with rendering. And everything is extensible in the Python language. So you can write programs for it easily. And then people contribute add-ons to it. And so there's a add-on manager. Let's see. I thought it was in tools. I forget where the add-on manager is, but there are add-ons you can add that extend it, and there's a number of community add-ons that have been added to extend it. So then SolidWorks. SolidWorks is its biggest limitation is it only runs in Windows, but it's very, very popular for engineering. It can do what all these other tools does. It handles complexity really well. So many large-scale engineering designs are done in it. It's really good when you have teams of people and you're making more complex designs. And then XDesign is a new thing coming out, which is SolidWorks in the cloud. And so it looks like SolidWorks, but it only runs in the web browser. So it works in Linux or Macs because the back end is running in their cloud and the front end is just in your browser. But in fact, the back end of this is really overlaps with CATIA, which I'll talk about. Now, SolidWorks is part of Dassault. They're great supporters of the Fab Labs, and they provide licenses for this for use in the Fab Academy. And so there's an issue tracker for the staff, and if you want to use SolidWorks or XDesign in your lab, send a request to the issue tracker, and SolidWorks will provide licenses to use it. And once again, the strength of SolidWorks is dealing with complexity, one of the strengths. And then XDesign has a back end based around the internals of CATIA, which is what you literally use to design jumbo jets. And so it's significantly scalable for handling complexity. And so they're very generous in providing licenses for the Fab Academy. The original author of SolidWorks is John Hirschstack. He started Onshape, and Onshape is a cloud editor. And so it looks and feels a lot like SolidWorks. It's a bit like XDesign, but running in the cloud, and it's really designed around collaboration. So Onshape, sort of, if you're familiar with Google Docs and sharing a document with Google Docs, it's sort of like Google Docs for CAD. And again, they're very generous with a free educational program. And the leadership of Autodesk, SolidWorks, Onshape for these are all good friends of the Fab Lab network. They're eager to support us. And if you have questions or issues that really need them, we can couple your questions and feedback back to them. So then there's a suite of tools: Maya, Alias, 3ds Max, Cinema 4D, Houdini. These are all modeling and rendering tools used for special effects. I don't really recommend them as CAD tools. Again, they're great for rendering and for Hollywood special effects. Then the founder of Dassault Systems developed CATIA. CATIA is a very high-end CAD tool. The real breakthrough with CATIA was taking whole jumbo jets from Boeing and Airbus and building the whole airplane in the computer, not prototyping and building subsystems, but designing and testing the whole program, the whole billion-dollar jumbo jet development, multi-billion-dollar, in a computer before you build it. So CATIA is really difficult as a beginner because it's designed to do a billion-dollar project with a team of people all around the world, but handles enormous complexity and handles the whole life cycle of design, fabrication, modeling, production, sales, service support. So CATIA is from Dassault. There's Creo, NX, and underneath those, ASYS and Parasolid. These are the really high-end commercial tools where an installation of them could cost $100,000. But to come back to XDesign, the back end of XDesign shares the real core internals of the CATIA engine. So one of the interesting things about XDesign is the scalability of the back end behind it. I'm skipping over a few links, just keeping an eye on time. So OpenSCAD is very different. OpenSCAD is a functional representation modeler. And so the distinction there is if you have a sphere, these other tools model the sphere as patches of the surface of the sphere. In a functional tool, you have a formula. So if you take x squared plus y squared plus z squared minus r squared, and you take that formula, it's a function. It's negative inside the sphere. It's positive outside the sphere. It vanishes on the boundary, and the magnitude grows around the boundary. And so it's representing an object as a function, not as patches of the surface. That's much more powerful mathematically, but it's harder to use. But there's been a lot of progress in the speed of computers and the speed of the solvers. So OpenJSCAD is a version of that in the browser. So here's a cube subtracted from the sphere. So I'll make the sphere smaller. So small you can't see it. Let me make it bigger. So each time I do this, this is describing how the parts get assembled in a hardware description language. It's producing a function, and then it's solving that function to make the shape. And so it's a very different kind of modeling where you describe the relationships of objects through functions. Matt Keeter, who wrote the thesis I linked, originally wrote a solver for these in what was in what's called the Fab modules. That became a program called Cocopelli. That became a program called Antimony. And then the current version of that lineage is a library called Lib5. And so this is a functional representation solver, and it's very different from the other things I've shown you. So what I'm going to do now is this is an anemone. And so I'm going to start adding a shape. So this is like what I did before. There's a cube. There's its data. And then here's a sphere. And so this looks so far like what I did before. So one difference now is this is a node editor. So rather than a history, I'm making a graph of the construction. So here I'm doing the Boolean operation, but I'm making a graph of how the parts relate. So now I can edit the sphere and subtract it. And each time I move it, you see it blinks a little bit. It's solving the function. And in a little while, I'll show you why that's so different. Now what I'm going to do is, rather than clicking clone, I'm going to recreate the object and then do another Boolean. So I'm not clicking and making a history, I'm making a graph of how the object is constructed. And so now I can go back to the original one and it propagates through the copy. But now what I'm going to do, before I do that, I'll do one other thing. I'm going to add a node. And so this is like the spreadsheet in FreeCAD. I'm going to add a node. And in this node, I'll make a variable. And then I'll use that variable in my design. And so instead of that being a number, I'll refer to that object. So I can come to that node and I can edit the design. But now what I'm going to do is, because an object is a function, I can do things like I can twist it and shape it and bend it. You can manipulate the object because it's a function. So watch this. I'm going to add a transformation. And this is a repelling node. And so this is a node that the object doesn't like. So now what I do is, as I move this node around, you'll see the whole object is warping. So I'll do that again. As I move this repelling node around, I'm morphing the whole function. The object morphs and deforms around it. It's still parametric, it's still hierarchical, but I'm deforming everything because the object is a function that I can manipulate. So now I'll do something even crazier. I'm going to add a torus. And then because an object is a function, there's a notion of an object in between other objects. So what I'm going to do now is I'm going to morph. If I go one side, I have my crazy object. On the other side, it's the torus. And I can continuously go between the torus and the bendy, morphy, twisty object. Because an object's a function, and so there's a notion of an object between other objects. So functional representation modeling is a really powerful abstraction for manipulating objects. So you can do that in Anemone, and FreeCAD has an OpenSCAD workbench. And so as part of modeling, that's great when you want to be able to like smush and manipulate an object. Mods is something I wrote, you'll see, to do workflows. And mods also has a basic FREP solver. So if I produce this and I look here, here is an object, but it's being controlled by this graph. And so if I Here, I'm going to add a server module object view. And so if I take this object, this shows you, this is the function that when you solve it gives you this object. And so all this is actually using, this module uses the GPU, the graphics processor, to solve an FREP. And so like if I'll make this shell thinner, or if I make it thicker, it controls the thickness of the object. I can change the view. So like this is X-raying to see inside the object. This is lighting the object. I can change it from an open to a closed lattice. And all of this is being done using the GPU to solve these distance fields. And so it's still a work in progress, but there's the beginnings of an FREP solver right in mods to do CAD with it, right in the browser. So here there's nothing to install, it's all on the client. And then finally, GrabCAD is a site for sharing designs, and it has a really handy viewer. And so you can paste their viewer into your site to be able to make an interactive viewer of your 3D designs. Okay, so that's a tour through types of 3D CAD programs. When you're done, you won't likely pick one of these. You'll use a mix of these, because if you take all of these attributes, they vary in their strengths with them. But the main thing you should do this week is try as many of these as possible. This is like dating. Everybody has different opinions of what works well for them, and there's no right answer. And so what you should do this week is try as many of these as possible and just see which one works for you. And you're all likely to end up with different mixes of tools you're comfortable with. But I would focus in among them is Fusion is beautiful with free education. SolidWorks and XDesign give us great support. SolidWorks is huge existing engineering base. It is Windows only. XDesign is their new tool, works on anything. And FreeCAD in particular is freely available, open source. And all of them have matured nicely and are beautiful tools. Now, one of the challenges is interchange. So you're going to design something, say in FreeCAD, let's see, Bridget was asking about large-scale projects. All of these tools break with complexity. When the project gets big enough, it breaks. Of the ones I mentioned, probably the most scalable of all is CATIA, because Boeing or Airbus use it to design a whole jumbo jet. And so in many ways, although it looks simple, the back end to XDesign and it's merging into SolidWorks is this enormously scalable back end. You have to be pretty ambitious to break these tools, but all of them do break as you push complexity. So interchange. You might design something in FreeCAD. You want to render it in Blender, but then you want to send it to a shopbot to mill. And so you need to move files between the tools. This is a very frustrating subject. DXF is one format. I recommend do your best to stay away from it. It's not a properly designed format. It's a file format from Autodesk that's lived way beyond where it should. There's sort of internal inconsistencies. There's multiple versions. When you open and close stuff, you get different versions. I don't really recommend it. STL is a really simple format for 3D printing, was where it started from, and it just represents triangles. What's good about it is it's only triangles. Nothing can go wrong. What's bad is it's only triangles. You lose all the design intent. OBJ is a pretty good format that was a file format that's turned into a widely supported one that's a bit more complex for geometry. Aegis was an attempt to make a better standard for it. And I'd say STEP right now is the most mature standard for interchange that comes closest to, if you look at the examples I did, I showed all these different relationships in the design. STEP goes furthest in retaining design intention, not just how it looks. And then finally, Alembic is a format used in like CG production pipelines. And so you're guaranteed to run into troubles exporting from one porting program into another, and you'll need to experiment with the formats for interchange. A lot of frustration with that. Let's see, somebody's asking about 123D design. The 123D design tools, those keep evolving. Autodesk keeps rearranging the entry-level tools. You can use them to start, but I really don't recommend them for this class, because all the things I'm showing you about hierarchical, parametric, algorithmic design, you won't be able to grow into it. It's fine to get started, but you'll outgrow it pretty quickly. Game engines are a really interesting subject. These were developed to develop video games, and if you play video games, you're in them. Unity and Unreal are the main leading competing ones. Both of them have evolved to two crucial things. One is, in their competition, they have free versions, and in their competition, they have versions that run in browsers. But what's interesting about them is they've both matured into full graphics environments. You can model geometry in them, you can render it, you can interact with it, and you can, in fact, make interfaces into physical devices and do real-time interaction. And these have gotten so good that we're just crossing a threshold now where production quality Hollywood movies are actually just being made in these environments, where you build a whole world in it interactively, but you produce it photorealistically so good it looks like a Hollywood quality movie. And so increasingly, you can actually do this whole class in a game engine. You could use the game engine to do the modeling. You can export files from it. You can interface the game engine to hardware devices we'll be developing. And so you can, and some people do, actually do their classwork completely in the game engine. The great benefit of it is, in the game engine, right from the beginning, it's interactive, immersive. You can do it on the screen. It can be VR. It can be AR. What you design is in a world where you can interact with it. They haven't yet caught up on the real CAD strengths I've shown you, but you might design your assets in a more serious CAD program, but use the game engine as a way to compose them. And so if we take the volleyball example, you might use a CAD tool to design the actual pads, but use the game engine to build the world where you model testing the volleyball system. And so I do strongly recommend look at the game engines. They've become really powerful. They're really interesting environments. And if you like them, you could do the whole class just working in the game engine as kind of your home place. Two more topics. Simulation is, this is a class I periodically teach. The notes are online on the math of how to model systems. I won't talk about it, but there's links there. COMSOL is a commercial multi-physics tool, few $1,000s, that lets you model forces and heat and airflow and fields. And so if we take like the helmet and you want to model how well does the helmet pull heat from your head out, this is a sort of tool where you can do that. Dassault SolidWorks has a very powerful simulation module, and part of the Dassault system is Simulia, which has Abacus, which is very high-end simulation. And so if you're using SolidWorks, there's a very powerful simulation framework for it. And then if you're using Fusion, one of the strengths of Fusion is it has a really good modeling environment. It doesn't do all kinds of physics, but for core things you want to do, like the loads on a structure, Fusion has the modeling built in it very nicely. What's hard about these modeling environments is getting your design into it and then getting the answers out of it. So in Fusion, it's nicely integrated. And again, simulation in SolidWorks. ANSYS and Nastran are high-end ones. And then there are these two interesting ones. Open Dynamics Engine is a development kit for doing physics. And so this is used in a lot of other projects as a modeling environment. And so for like, if you have a game engine and you want to model the physics in the game engine, this is a physics modeling. And once again, it's used in many other projects. And then Modelica is an EU project along the same lines that has all kinds of modeling tools, and depending on the version, is freely available, open source, and can do many different types of physics, all shared through that. And so this has been evolving as a really interesting, powerful modeling tool. So those are both options for modeling your project. Then the last thing I'll cover is audio and video. So as you work, you're going to be making videos documenting your work weekly, and later in the semester we'll want you to make nice videos on your final projects. So you'll need to be comfortable with audio and video production. This is just a link to a tool for screen recording, like the videos I've been showing you. From Linux, I use this. This is a lovely tool for Linux screen recording that can do audio and video and what's happening on the screen. Audacity. So what's happening is the desktop you're looking at is a virtual machine in Amazon Web Services. And periodically, because bad things come out of people using virtual machines, it gets banned. So Audacity is blocking AWS. So Audacity, that's surprising. Audacity is a sound editor, freely available cross-platform, really powerful but easy to use. Strongly recommend it. So if you have audio recordings, if you want to merge multiple streams, if you have a screen recording and you want to add narration, if you want to add a soundtrack and you need to edit the soundtrack, Audacity is a really good sound manipulating program. Really recommend that. Then for video editing, I'm a big fan of Kdenlive Live from Linux. Kdenlive Live is a nonlinear video editor. And so it lets you bring in assets, which can be video clips, it can be pictures, it can be chunks of text. And then it lets you slice and dice them. So you can have a timeline of editing different parts of the video. You can have a soundtrack, all kinds of effects where you warp and fade and zoom in and zoom out and transform. And so everything you need to do nonlinear video editing to make a video out of video and many other kinds of assets. It's for Linux, really powerful. It's what I use. Really strongly recommend it. With the one note that the standard distributions have out-of-date versions. And so if you're using Linux, it supports what's called AppImage. AppImage is the program bundled with everything you need to run it. And so you should always be running the most current version. The version in the repositories are out of date. But this is what I use for nonlinear video editing. Really like it. I really recommend it. Two other ones that are freely available. One is OpenShot, and Lightworks is a very high-end one, used again for high-end, but has easy accessible versions. And so those are versions for nonlinear editing. Like as part of the Adobe Creative Suite, like Photoshop and Illustrator, there's Premiere as a paid tool. But you'll need one of these. You'll need the ability to make videos and edit videos for the class. Once you have videos, then you'll need these kinds of tools. So FFmpeg, again, with one of these historical forks, libeAV diverged from it. There's mencoder. But all of them let you do for video what ImageMagick did for images. So in the same way ImageMagick lets you cut, copy, edit, manipulate pictures, these let you do it for videos. And so for FFmpeg, oh, and then one other thing, MPlayer and VLC are media players. One issue with playing media is compatibility with the different encodings. And these are freely available tools that play every kind of encoding. So now we get to making your videos for your websites. So HTML5 is a set of extensions to HTML. And very importantly, they added audio and video. There's a subset of the formats. And within the subset of the formats, these play in browsers without plugins. So if we go back up to in this class where I've been showing you these videos, these are encoded so they play in your browser without a plugin. They just start playing. And all modern browsers support it. And so this is now an important page. This is a series of cheat sheets. When you make your video, it's almost certain to be much larger than it needs to be for the quality on the website. And so your demonstration videos should be megabytes, not hundreds of megabytes. And so you need to be comfortable with transcoding them. And so your video production tool may have some good options for that. But it's so easy to do this with FFmpeg, which again is freely available cross-platform, that you export a video with your tool however it's happy doing it, and then you can use this to prepare it. And so this will take a video. Here's where I say I want to use the X264 codec, which is one of the ones supported on the web. This is where I pick the quality. And this one says, rather than the bit rate, I just pick a quality and it picks the bit rate. Here's where I say I want to rescale it. So I want it to be 1080p. I pick the resolution. Then here I'm picking the codec, and here I'm saying I want MP3 audio. Here's the data rate, and then I make my movie. For some things, it's better to let the tool pick the data rate, and you pick the quality. Alternatively, you can have a fixed data rate, and sometimes you get artifacts if things rapidly change, and so you let it fix the data rate. So here I bring in my video, and again, this is whatever format my video's in, but now I'm going to pick the codec, I'm going to pick the bit rate, I'll pick the resolution and the encoding, and I'll make my video. Now, again, you may think you don't need this, but one thing this will do is it'll shrink by like 100 to 1 the size of your video. But the other thing is, unless you do this, you won't be able to play the video in a web browser, that you'll need a plugin. And so you need to transcode to one of the web's formats. And so this link here tells you about the formats that you need to play on the web. But this is just a cheat sheet of ones that work. Here's an example making a video with no sound. Here's an example where you crop it, where you might not want all of the original video, so this can trim parts of it. you might not want all of the time. And so it lets you trim the time, picks when you start and stop. You might have separate audio and video. This lets you mix them. And as a final really fancy one, this is an example of cropping, panning, and compositing. Compositing is where you have more than one video on top of each other. And all of those operations you can just do with FFmpeg. And so simple tasks, you don't even need a video editor. You can just do it all with this tool. But crucially, you can use this tool to compress and transcode so your videos play on the web without needing a plugin. Okay, so as you start making videos to document your work, and I'll add a note, you should almost never use an animated GIF. The reason why is animated GIFs, which are all over the web, the image quality is very poor compared to these current standards. Where animated GIFs are good is where there's just a couple frames you want to show as discrete frames. But GIFs seriously reduce the image quality, and they're also huge compared to these. So there's now almost now that video plays on the web, there are very few cases where you'd ever want to use an animated GIF. It's good for just a couple frames. At this point, you should use these more powerful video formats that are much higher quality while being much smaller size. So stepping back, this class introduces tools. You're going to spend the whole semester learning about them, mastering them. At the end of this week, you won't have mastered the tools. At the end of this week, the goal is just to have them installed and to be started using them. But you want a 2D tool for working with images. You want to be set for compressing your own images. You're going to definitely want a 2D vector. So for a 2D tool, if in doubt, GIMP is a great starting point. For a 2D vector tool, Inkscape is a good starting point. Then for 3D tools, you really want something that's hierarchical, parametric, algorithmic, all of these properties I've been stressing. And so I would look at FreeCAD for freely available cross-platform, Fusion for nicely integrated workflow, but you do have to use it connected to their cloud. SolidWorks for industrial strength CAD that runs locally if you're using Windows, XDesign for the same sort of thing in the cloud, or Onshape for something that's sort of like Google Docs, but for design. And so no one of those is right. Look at all of them, see what appeals to you. But all of those have the headroom to take you through all the things we need in the class. You really, just to repeat, if you look at next week's assignment, we're going to cover vinyl cutters and laser cutters. But at the end of next week's assignment, you're going to make a construction kit. And for the construction kit, it needs to be parametric so that if we go back to, and I'll tell you more about this next week, you'll have a design, and if you change the cardboard thickness, all these slots need to change. And so this week, you need to learn a tool that can propagate parameters through your design to be ready for next week. Then look at the game engines. You can look at these simulation environments. You definitely need to get set up for working with video. And then finally, what I want you to do for this week is take a potential final project, it might change, and just represent it as many ways as you can. Draw a sketch on paper, draw in a paint program, make a 2D drawing, make a 2D vector drawing, make a 3D outline, put it in a renderer. All of the CAD options I mentioned have hooks to renderers, or you can export and bring it into a tool like Blender. And represent your design as many different ways as possible. Once again, at the end of this week, you won't have mastered these tools, but you will have met them. And the real goal is to just get them installed and get you working with them to be ready for the design work to come. Okay. Any final questions or comments? Global silence. Let's see. Either it's all clear or you're all snowed under and overwhelmed. Probably some of both. Okay. So if there aren't any immediate questions, remember spiral development. So don't spend all week learning one tool, learn a little bit about each tool. Remember, document as you go. Don't try to push your work just before class. Keep a log of your work as you're progressing. So when you're done, when we get to class time, you're done. You don't need to design. Sorry, somebody posted a question about a plugin to edit videos. I'm not sure what the question is.
Hello, Neil.
Yeah.
I am Mershi from SEP University.
Yep.
I am using a Markdown language, continue and starting exploring Markdown.
Yep.
But I got a pipeline / my code name has failed for master. I got 70 failed pushes.
I can't debug that. Let's take that as a particular example. I can't debug that just from your description. So there's a sequence. A problem like yours, first start in your own lab and ask if any of your peers and your instructor can help. If you can't get help, each of you should be part of a regional review with a regional guru. If you can't get help there, post it to the class issue tracker. In the end, ultimately help with the site goes to Fiori, but we have to protect Fiori from all your one-on-one questions. And so post to the global issue tracker if you can't get local help. Let's see, there's a question about licenses. So again, Fusion is freely available for education. Onshape is freely available for education. If you're just starting, I don't recommend AutoCAD or Inventor. Autodesk's focuses on Fusion. And then FreeCAD doesn't need a license. And then SolidWorks or XDesign, your instructors can post to the issue tracker and we'll get licenses for those from SolidWorks. So next week we'll pick up on meeting people, and then next week what I'll want to see is who used what tool and who likes what tool and what doesn't. And so hopefully over you, some of you will do simulation, some of you will play with game design, some of you will use each of these options. And now that we're underway, the weekly review will be much more than just meeting people. We'll learn about how people use each of these tools. So no recitation next week. We do that every other week. And then we rejoin a week from now. And that's when we get into the lab and start making things with computerized cutting. So happy modeling. And I'll see you all in a week. Bye-bye.
Bye.
Bye. Bye.
Bye.
Bye.
Bye.